The fight is on for 1/3 of the food we eat. On one side is a ferocious vampire mite. On the other side is human ingenuity. The battleground is Apis mellifera, the Western honeybee. This fight leads us to ask, can human ingenuity save the honeybee and our food?
Welcome to the award-winning Food Chain Radio Show with your host, Michael Olson. And now get ready for 1 hour of What's Eating What Radio.
Well, hello out there, and welcome to the 1400th edition of the Food Chain Radio Show and podcast. Or hey, perhaps you're among our friends down there in Punta Arenas who are tuned in as we stream along on the Food Chain page at metrofarm.com. Well, whoever you are and wherever you are, welcome aboard. I am Michael Olson, your host for this hour of What's Eating What. Folks, the fight is on for 1/3 of our food, and it is mostly the foods that make our eating so enjoyable. Fruits, nuts, vegetables, spices, and herbs. The fight is between a ferocious vampire mite that plants itself on the bodies of honeybees and literally sucks the life right out of them, and the human ingenuity that tries to prevent this depredation. In a sense, the fight is similar to that of a farmer who must find a way to keep the fox out of the hen house. Only these hens are the honeybees that provide for 1/3 of the food we eat. Sad to say, it appears as though the varroa mite is winning the fight, as the population of American honeybees is in a state of collapse. Though there are a number of reasons why this year has been so devastating, one of the big reasons is that the varroa mite has apparently developed a resistance to one of the principal weapons humans have used to control them, the miticide amitraz. Lacking an effective defense, there's nothing to stop the varroa mite from getting into the hive and sucking the life out of our honeybee food chain. And so the fox is in the hen house. What to do? Well, either we humans come up with a new miticide that will hold the line against the varroa mite until it becomes resistant again, or maybe, just maybe, we can figure out how to breed a better bee, a bee that's smart enough and strong enough to stand up and fight off the mighty mite on its own. And so we ask, can human ingenuity save the honeybee and our food? Well, who better to ask than Garrett Slater, who is the extension entomologist at Texas A&M University. Dr. Slater, welcome to the Food Chain.
Well, thank you for having me. Pleasure to be here today.
Well, great. First of all, I have a question for you. Why is it that North Dakota is the honeybee capital of America?
Well, mainly because the average colony produces, 200 pounds of honey. And just a little context of that, in Texas, they may produce 50 pounds of honey. So about 800,000 to 900,000 colonies every single year migrate to North Dakota just for honey production. So, there's sunflowers, canola. It's just really one of the last great places for bees in the world.
Why does North Dakota have so much fuel for honeybees? So what is it about North Dakota?
Well,
Why not New Mexico?
Yeah, really the lack of people is part of it, but then there's this fields and fields of wildflowers. So you have just fields of alfalfa, sweet clover. It's a really agriculture area, so they have a lot of, food products for bees. And so it's just a really great place to go up into the summertime to produce honey.
Good. Why not Iowa, which is the heart of the heartland?
Yeah, so I mean, mainly Iowa, right? There's, fields and fields of corn and sweet clover, or not sweet clover, but corn and soybeans. So there's a lot of crops that aren't valuable to bees, whereas North Dakota has a lot of the rangeland, has a lot of investment into conservation land. So, North Dakota, South Dakota, they just have, a lot of resources for bees that other states don't have.
Well, we know that a lot of your bee education took place at North Dakota State. And you being a North Dakota boy, I'm just wondering, did you go to North Dakota State for the bees, or did the bees get you while you were at North Dakota State?
Well, actually began really, really before that. So my uncle, he was a commercial beekeeper, and so he managed around 10,000 colonies. So I remember when I was really young, my earliest memories was I was like 5 or 7 years old, going to the colonies, getting around bees. So I guess I've always had the itch, even at a really young age. So even before I went to North Dakota State.
So it was always there. But something along the line made you decide, yes, it's the bee for me. What was that? Do you remember that moment in time?
Yeah, so really, really the major moment was 2005. So, I've always wanted to be a beekeeper, be in bees in some way. But around 2005, beekeepers started experiencing these massive colony losses. And you probably remember that colony collapse order, CCD. It was in the news, bees were dying everywhere. And
Yes.
that was including my uncle and a lot of close beekeepers that I worked with in my local town. So they were losing like 80% of their colonies, which was just unheard of. Before that, beekeepers may lose 10 to 50% of their colonies, but really that moment changed beekeeping and really changed the industry forever. So I decided just to focus my career on research and extension and really trying to help beekeepers. And I guess I want to say my back from beekeeping too, but yeah, it's really fun to try to help beekeepers if I can.
And you got your PhD from Purdue, which is probably, when it gets right down to it, the nation's preeminent ag school.
Mhm.
There are many others, but Purdue always pops up there pretty close, if not on the top. What was your PhD thesis about?
Yeah, so at Purdue University, right when mites became a really big issue in the early 2000s, they launched this breeding program called the Purdue Mite Biters. And so they're breeding for a bee that could actually find the mites and kill them. And so I really want to work at that laboratory, work with that breeding program. And so that's why I became really motivated to work at Purdue.
So that was the focal point of the mite then, the mighty
Exactly.
mites. Good.
The mighty mite.
Well, yeah. So first, let's talk about the state we are in right now. We talked about there was a previous collapse of the colonies. I think it had something to do with tracheal mites, right?
It was actually viral mites. So tracheal
It
mites
was
out
viral
around,
mites.
yep, yep. So what happened in 2005 was mites became resistant to two other chemicals. So these two chemicals, fluvalinate and comifos, it worked really well for a long time. Then all of a sudden in 2005, mites became resistant to that chemical, and that caused these massive colony losses. So, beekeepers are really depending on those chemicals to treat and manage mites. But once it didn't work anymore, it just exploded and caused some of these losses. And so beekeepers started transitioning to a new miticide, amitraz, and it's been working for about 20 years or so. But now mites have finally become resistant to it, and we're kind of into a phase two of the problem, and it's become even bigger than it has been, really for the past 20, 30 years.
What kind of losses are we looking at? So it seemed like in January of 2025, things just all of a sudden fell apart.
Yeah, the losses are around 62%. Whether you're a commercial beekeeper or whether you're just a sideliner or whether you're a hobbyist beekeeper. So losses are massive. And these are probably the highest losses we've ever experienced. So it's typically around 40 to 50% each year, which is still really high. 50% of colonies dying each year is really high. But this year is up to 62%. And I think the numbers, maybe 1.5 million colonies died this past year. So it's a really dire situation.
Whew, that's a massive die-off. Well, how secure is our food chain with respect to bees then? Is it really true that bees are responsible for 1 in 3 bites of food that we eat?
Yeah, bees are just really important pollinators. So yeah, I mean, people throw out the number 1/3 of what we eat, which is probably true. They pollinate a lot of what we consume each day, and even for products that we don't think about. So here in Texas, we have cotton fields, and bees improve the yield of cotton. So they're really important for, really our whole food system.
So for the whole. Now, you mentioned the fact that bees are really under threat from what, 5 different things. You call them the 5 Ps: parasites, pathogens, pesticides, poor nutrition, and poor management. And then so I guess there's all kinds of stresses on the bee population when it gets right down to it. It seems though like most of them are related to people
Yeah,
and
yeah.
how we husband our bee populations. Am I wrong?
Yeah, I guess you could say that, right? We have the five P's, and two things like pesticides and poor nutrition are just, how we use the land, how we, manage our food and crop system, and this all have an indirect effect directly on bees and pollinators. Even from a beekeeper's perspective, they're managing colonies at a large scale, and the varroa mites are taking over, the viruses are taking over, so it's a really big problem, and unfortunately, there's five different reasons, and they all kind of interact together that drive these colony losses, and it's really not a new problem. We've dealt with these same five Ps for the past 20 years, and unfortunately, it doesn't seem to be getting any better.
And a lot of it has to do with the nature of how we husband the land, which it relates to the food that is available for the bees. And then, of course, in a place like North Dakota, where there's a lot of grazing land,
Mhm.
perhaps that becomes the most valuable source of food for bees because there's a tremendous variety of foods for them.
Yep, exactly. Like North Dakota and certain parts of the Midwest, they have a large investment into conservation, like the CRP programs. They have large investment into pollinators, and probably main reason is just for grazing land for these ranch areas. So they still have a big investment into, conservation. But the problem is, as land becomes more valuable to a farmer to be put into corn and soybeans, that takes away a lot of the nutrients away from bees and other pollinators. In order to manage some of those large crops, you have to spray more often to manage the pests. And so that all has an indirect effect or even a direct effect on bees and pollinators. So, it's one of those things where, is this going to change? Once it's taken out of conservation, it's hard to put that back in.
There you go. And then quickly turning, so there's a lot of work being done to conserve land that is valuable for bees and other critters as well, of course. And just to have it there as a land bank. Texas has done something very interesting fairly recently with respect to bees. They passed a law that gave tax exemptions to property owners for keeping bees.
Yeah. So Texas in 2012, one way to get exemption for your property taxes is to have honeybee colonies. So, if you're a property owner and you have somewhere between 5 to 20 acres of land, you can manage colonies on your property and get a massive tax exemption for that. So we've seen a massive influx of people get into beekeeping just for that. And one thing I think was really cool about that is people just understand how hard it is to keep bees. Next time they go to the store, they realize that, okay, that bottle of honey took a lot of time and a lot of labor to put that on the shelf. But they also realize the importance of that just for their land, right? That they increase the yield of some of their crops, their apples, things like that. So it's cool to see people have a different viewpoint on bees and how important they actually are.
So that people can escape some taxes by keeping bees probably makes Texas a honeybee hotspot. And so that puts you right on the hot spot yourself. If that's the case, you're going to have a lot of people seeking advice since you're the extension person there. Help, what do I do? How do I fix
Exactly.
this? Well, yeah. So
Yeah.
it's
So
you probably
yeah.
get a lot of calls, right?
Yeah, exactly. And this is a brand new honeybee extension program. Texas and Texas A&M has never had a honeybee extension program beforehand. So, I got this position last year, so we're starting to spearhead that program and provide some more resource for people that want to get into bees. Whether that's just for hobby or whether that's for their tax valuation.
Well, good, well, ladies and gentlemen, this is the Food Chain Radio program. Today we're taking on the mighty mite that's threatening the honeybee populations, the varroa mite. It is wreaking havoc. It's a very ugly, mean bug. And we're going to talk about what we can do now that we no longer have a miticide that will take care of that varroa mite. This is the Food Chain Michael Olson, and we're talking with Extension Specialist Garrett Slater, who has a PhD from Purdue University on bees. So we're going to learn a lot about what we can do to escape the varroa mite. Stay tuned for this is Food Chain Radio program. Let's see.
You have to move now. No problem. Store your stuff at Anbar Self Storage and U-Haul. Easy off Highway 1 on Airport Boulevard by the airport. 24/7 security. Drive it to your door and store it at Anbar Self Storage and U-Haul in Freedom.
You sold your motorcycle to a friend in Fresno and need to deliver it. Well, Anbar Self Storage and U-Haul in Freedom has motorcycle and car trailers ready to go. Easy off Highway 1 on Airport Boulevard by the airport. Anbar Self Storage and U-Haul in Freedom.
Greece is cheap.
But the airfare costs a fortune.
Paris?
Not much closer, and again, airfare...
What about Puerto Vallarta?
Let's face it, flying anywhere is just too expensive.
Wait, what's this? Low-cost airlines.
With one call to low-cost airlines, you'll drastically slash your travel costs. We're talking insanely low airline prices to any of your favorite destinations. Where would you like to go? London, Rome, Costa Rica, Australia?
Wow, that's cheap.
So why wait? Call now to learn how crazy cheap it is to fly anywhere in the U.S. or international. Our prices are so low, we can't publish them. The only way to get them is to call to instantly hear the most amazing best deals on airline travel. It's that easy. So call now and start packing.
800-704-1662. 800-704-1662. 800-704-1662. That's 800-704-1662.
Attention content producers. You can have access to a complete digital media production facility at Satellite Co-working and Digital Media Studio on Soquel Avenue. Easily rent video and audio equipment, a studio with green screen, editing suite, and audio booth, all at can't say no rates. Schedule a tour to see for yourself at satellitecoworking.com. Mention Santa Cruz Voice for 20% off your first reservation.
Cannabis is one of nature's most beneficial plants. Hello, I'm Jenna from Treehouse Dispensary in Soquel. In addition to the finest cannabis products, Treehouse dispenses information to those who want to know how to use cannabis for maximum benefit. Though we aren't medical professionals, we do know how cannabis science can help you. You must be 21, but no appointment is necessary, and the information is free. And for those who already know what they want, Treehouse has an online ordering option at ourtreehouse.io and drive-through pickup.
For ag and industrial real estate, call Chuck Allen. Chuck Allen is a lifelong resident of the Pajaro Valley, a friend of everybody, and has closed so many real estate transactions, the Wall Street Journal and Keller Williams both list him as one of the nation's top producers. So for ag and industrial real estate, call the top realtor, Chuck Allen, at chuckallenproperties.com. chuckallenproperties.com. Welcome back. This is the Food Chain Radio program. Michael Olson. We're talking about the fight over our food, and the fight is taking place. I guess the focal point of that fight is with the honeybee population of the United States, which is in a severe state of stress. Principally, I guess most people are pointing to the mite. The varroa mite as being the cause of this collapse that's going on as we speak. So tell us a little bit about this varroa mite. We often hear about mites. What the heck is a mite anyway?
Yeah, mite is basically a tick, right? It's a small red tick that feeds on the bees. They lower the immune system. They transfer these deadly viruses. Now, if you imagine yourself with a plate on your chest, that's how big the mite is relative to a bee. And it's not a new problem. It's been around since 1987. Its original host was a different species of bees, but then around 1910 they jumped host to Apis mellifera, which are the bees that we manage now. And then over the next 100 years or so, they made its way west into United States. Now these mites are really tricky, and they're tricky in one. It's really hard to develop a treatment for them because you're basically trying to get a chemical that doesn't kill the bees, but still kills the mites. So you're trying to develop an insecticide for the mites that doesn't kill the bees. So that makes it really difficult. But two, you kind of mentioned like a vampire mite. They hide inside the cells and hide away from any treatments and hide away from the workers. So they're a really big problem and a really difficult problem to deal with. So even though they're really not a new problem, they're becoming worse and worse and worse over the past 20 years or so.
So you talk as if we were a bee. It would be a plate-sized critter that would attach itself to us. How does it attach itself? What does it do?
It just basically attaches itself and then it feeds on basically the bloodstream of the insect or the hemolymph. So it attaches itself to the bee, has this like piercing device that goes into the bee and starts sucking up the blood of the bee, essentially. And during that process, it transmits these viruses. And so it's not necessarily the mites, it's the viruses that they transmit. And unfortunately for the viruses, we have no way to treat or kill the viruses. So the only way to manage them is by managing the viral levels in your colony.
How did the Amitraz miticide work? kill the or to control the varroa mite population?
Yeah, so essentially the treatment is like a plastic strip, and inside of it is embedded with amitraz. Amitraz is the active ingredient, and we know that it does kill mites, but doesn't have any side effects on bees. And so beekeepers started using that really regularly since 2005, and it's worked really well. And we haven't seen resistance until probably the last 5 years. But over the past 5 years, we're seeing that, well, it's killing the mites that aren't resistant to it, but the ones that are, the mite populations are exploding. They're transferring to other beekeepers, and now we see, most beekeepers have mites that are resistant to amitraz. And we even sampled colonies that were dead in California this past spring, and those dead mites had resistance to amitraz. So it's a really big problem because this is something that beekeepers really rely on, and it's worked for a very long time. And what's the next step for beekeepers?
There you go. Well, I guess it's worked for 20 years, and it was effective for 20 years. But after 20 years, you pretty much select for those mites that won't be affected by amitraz. By
Exactly.
continuing to use the same poison, you're looking for bees that essentially won't be affected by it, and then you're in trouble again.
Yep, and beekeepers weren't rotating treatments, right? They're primarily using this one treatment, right? And if you keep using the same treatment over and over and over among millions and millions of colonies, it's likely that they'll become resistant to it.
Well, is there an alternative to amitraz? Was there an
Yeah.
alternative to amitraz?
So right now we do have alternatives, but the one problem is Amitraz works really well, almost too well. And one, it's beneficial because you don't have to use it, you can use it any time of the year. So heat isn't a problem. Whereas these other treatments, you can apply them when it's above 85 degrees. And so you think about places like here in Texas and California and places where it's above 85 degrees like 9 months out of the year.
Even North Dakota.
Even North Dakota, yeah, it can basically scorch your entire colony and your queen. So, it worked really well because temperature wasn't an issue. It'll kill the mites inside the brood cells. So there are alternatives out there. They just don't work as well as Amitraz has.
Are there other mites? I remember a lot of discussion about tracheal mite being a big problem of some years back. Is that still an issue, or is that something that amitraz took care of as well?
Yeah, so tracheomites was a really big issue in the mid 90s. And what tracheomites did was they actually went to the trachea, or basically, where the bees breathe. But really, ever since beekeepers started treating for varroa mites, we haven't seen even cases of tracheomites. There is a new mite that is in Southeast Asia, the Tropicalaps, and that could even be more devastating than varroa mites. So currently, it's making its way out west. There's some reports, kind of Russia, Ukraine, and so if that becomes president of the United States, that could even be more devastating than varroa mites. But currently, it's just varroa mites in the U.S.
So one problem then. Um, and we have no problem, we have no control over it right now. Is that correct? Is that the situation that's causing the collapse of the bee population? We have no control left with amitraz?
Some beekeepers might, some beekeepers don't. But the problem is if you apply the treatment, you have resistance, it's not going to work. So, eventually all beekeepers will probably have resistant mites in their colonies and it just won't work anymore. And so one thing we try to push is, hey, do some testing to make sure that this treatment will work and the mites aren't resistant to it. But it's just something that beekeepers just can't rely on anymore, in my opinion.
Wow. Okay, it was easy and now it's not easy anymore. And this is a huge problem if you're having a commercial business in beekeeping. And really briefly, how does the commercial beekeeping industry work? Because a lot of us are familiar with the backyard beekeepers, but commercial enterprises are working on a whole different schedule there, a whole different level.
Yeah, so commercial beekeeper typically has somewhere between 500 to even 100,000 colonies, and their main income comes from like two different routes. One is honey production, and then two is kind of commercial pollination. So for most commercial beekeepers, they kind of start in Texas. They split their colonies in half to make up for their lost numbers. They make new queens, and then they ship them up to the Midwest for honey production. So whether that's Minnesota, North Dakota, even Montana. After that, they ship the bees to California for pollination, primarily almond pollination. Some overwinter in California before they go back to the Dakotas, but other ones go back to Texas. So it kind of depends on, the commercial beekeepers, but most are kind of following that three-state migratory route.
So commercial beekeepers means being a truck driver too, then, because you're hauling colonies all over the place.
Oh, exactly, exactly. So each truck, so if you see one on the side of the road, they're carrying about 400 colonies, 420 colonies. So, if you have 10,000 colonies, you can do the math. So there's a lot of trucks that are shipping across the country. And some even go to Florida. So they're shipping bees from Florida to California to other parts of the country. So, bees are shipped in every part of the country for pollination or honey production.
Well, that's a significant stressor on bees as well, is it not?
It is, yeah, exactly. So when you're on a truck and you're shipping them, I mean, from Florida to California, for example, that takes 4 to 5 days on the back of a truck. So you include heat stress, you include just vibrational stress of the truck, you include all the other stressors. So that's something that's, probably plays a really big role.
Yeah.
So it's like if you're stressed out, that makes all these problems even worse, right?
It
Compounds the stress.
Yeah, it makes you more vulnerable to everything else. And
Exactly.
talking about everything else, you had the five P's, and of course, the mites are one of them. But pathogens, you mentioned pathogens as being next. What exactly do you mean by pathogens?
Yeah, so bees can be exposed to a lot of different pathogens, right? There's bacterial pathogens, fungal pathogens, anything that any type of livestock deal with. But the major pathogens are these viral pathogens. So there's about 23 to 26 different viruses that can get into a colony, infect a colony, and most of them are directly transmitted by the varroa mites. Now, the problem with the viruses is we don't have a vaccine or way to kill the viruses. So once they get really high in a colony, you're kind of in a tough situation and your colonies are likely to crash. So probably what happened last year was the treatments weren't working, the mite levels got really high in the colonies, they had more viruses, and then they started crashing last winter into the spring.
So viruses or the pathogens left behind by the varroa mites are probably a big cause of that then.
Exactly. And one problem with the viruses is they're rapidly evolving. So, one common virus is deformed wing virus. It actually causes the wings to become deformed where the bees are unable to fly and they die within a couple days. And now there's three variants of that. And so these viruses are rapidly evolving. They're becoming extremely virulent and, even more deadly.
Kind of like COVID, I guess. Gets
Yeah,
right down
exactly.
to it. A lot of changes going on there. Pesticides, of course, are a big issue. We have insecticides, we have herbicides. All of them have a direct impact on the body of a bee.
Yeah, so for insecticides, right? If you think about an insecticide, it's developed for an insect pest. So any type of insecticide that's going to be used is going to have some sort of impact on bees. Maybe not a huge impact, but it's going to stress out the bees, maybe cause some losses, or even make the viral problem, even virus problem, even worse. Even fungicides, some fungicides can be toxic, and herbicides are taking away a lot of the important nutrients for bees in the spring, like dandelions, clover, things like that. So it's something that's being used, across the country. And I totally get farmers depend on this to manage their crop pests, but it's also having an impact on the bees.
And of course, when you have hives near a commercial farm or a commodity crop of some kind, they're going to be spraying it, and you can't be moving the hives every time they spray, can you? How does that work?
You could, but it takes a lot of time and a lot of stress. If you're managing, thousands of colonies, there's no way you can move all the colonies. Like if you can, you can move the colonies away from the spray, you could cover the colonies with a net, but oftentimes beekeepers have colonies, miles and miles away, so it's hard for them to even do any intervention.
So there it is. They're just vulnerable to those things um, that are used in agriculture to kill pests.
Yep.
And they're not a pest, but there's the same poison can get to them that is used on the pest. So
Yep.
a
And
significant issue there.
yeah, and bees are flying in a 3 mile radius, right? And so when they're flying in a 3 mile radius, you could be a farmer and you could alert, the beekeeper, but you can still be exposed in a pretty large area. So
Yeah.
that makes it even more difficult. Because I do think a lot of farmers, want to help the bees out, but it's also hard for them to talk to beekeepers and know which colonies are even around the area.
Is there a way to measure the impact on bee populations with pesticides like insecticides, all the rest of them are used.
Yeah, so we can definitely get the wax. So, a honeybee colony, they build wax inside the cells, and that's hydrophobic, so it absorbs everything from the environment. So if a beekeeper suspects a pesticide kill, we can test that wax to see what's actually in the wax. We can also collect worker samples to see if they were stressed by pesticides in some way. But really, at the end of the day, if you're sprayed by pesticides, what do you do in that situation? It's kind of tough.
There you go. So poor nutrition. Pretty easy to see how poor nutrition could affect bees when you place a population of bees in a commercial field where there's commodity crops growing. They tend to grow fence post to fence post, and they tend to have one kind of crop growing, and there's not much else for the bee to feed on, correct?
Yeah, so bees like to forage on a lot of different flowers. It's not like bees just go back and forth between sunflowers or canola. They like to get resources from a lot of different flowers. And so that's why it's really important. They want to get pollen, a diversity of pollen, diversity of nectar. And so, they forage on a lot of these different crops. But when bees are kind of forced to forage on one crop, they may not be getting the right nutrients or the right amount of nutrients they need, and that could stress out the colony, whether that impacts honey production, but also make them more stressed out and lead them more prone to the viral mites or viruses or some of these other factors. So yeah, nutrition is a really big factor.
Good. And then finally, a poor management. What would that be?
Yeah, so poor management, and this is more like there's things that beekeepers can directly do to maybe not directly eliminate all these factors, but lower the risk of them, right? So one could be, you're basically just putting your bees in, blueberries or some crop that that they're going to be sprayed to, right? That could be poor management. Or maybe you're not using the right integrated pest management strategy, right? So to deal with the viral mites. Or maybe you're a new beekeeper, so you don't know how to properly manage the colonies in a way to keep your colonies healthy and strong. So, I really think that a lot of things beekeepers can do can really help with the colony health and survival.
Probably some good planning and some good education would help a lot when you start the business, because otherwise you're going to end up with some pretty sad situations. Well, folks, we're going to take a quick break, but when we come back, we're going to talk about what we can do to solve the bee problem, and we're going to look at what we might be able to do in building a better bee, which is the job of Garrett Slater, who is a Texas A&M University Extension entomologist, whose job now is to build a better bee. So look forward to hearing about that. So do stay tuned. We will be right back.
When the going gets tough, the tough get going to Santa Cruz Electronics, where they get all the electronic information and equipment they need to fix electronic gear themselves and save money. Hello, Charlie Friedman here. Listen to the things your friends and neighbors are fixing themselves with the help of Santa Cruz Electronics.
Solar energy kits for school science project.
Musical Tesla coil. Video output for my home media center.
Building a new server for doctor's office.
Repairing a student radio station.
More RAM and a sound card.
DSL line.
Network printing, scanning, and faxing for dentists.
Wireless network for court reporter agency.
Diagnosing sound card problem.
Ham radio antenna.
If electricity flows through it, you can probably fix it yourself and save a lot of money with the help of the experts at Santa Cruz Electronics. Voted Best Electronics Store 2 years running, call Santa Cruz Electronics today at 831-479-5444. That's 479-5444. Or visit at 2808 SoCal Avenue in Santa Cruz. Fix it yourself and save money with the help of Santa Cruz Electronics.
If you love cats, if you love dogs, or horses, pigs, birds, or frogs, there's a lot of ways to help if you're sincere. With a little bit of money, or you can volunteer. You'll save a life when you adopt. You're just getting started. Please don't stop. Right here on the Monterey Bay, you can save some critters with the SPCAs. Open up your home, donate a car, or pull some bucks from your small change jar. Give a little love, share a little time, save a little life gain peace of mind. All the SPCAs of Monterey Bay.
Windows are a way to see and a way to be seen. Hello, I'm Guy Mitchell from Lighthouse Windows in Santa Cruz. Lighthouse Windows installs doors and windows in homes and in new construction. We make a big difference in how you see and how you are seen. Listen.
My name is Alice Nicolaisen, and we're residents of Santa Cruz County. Took him one day to put the windows in. You'd never even know they were here. I love the looks of it. I like the grids in the front, and we decided just to have the plain windows in the rest of the house, but it really dressed up the front of the house. When the windows and the doors are shut, you don't get the outside noise. All the neighbors, when they'd walk by, they commented on the windows and in turn asked us who did it. We told them, and they have had some done themselves.
New windows and doors from Lighthouse Windows will keep your home warmer in the winter, cooler in the summer, and quieter all the time. So when it comes time for you to improve the way you see and the way you are seen, call on the window and door specialists at Lighthouse Windows in Santa Cruz, 426-2601, 426-2601.
Welcome back. This is the Food Chain. Michael Olson. Today we're talking about standing up to the environmental threats to the honeybee, which is the source of approximately 1/3 of the food we eat. Somehow we have to figure out how to save the honeybee. Or else. Can you think of a better way of putting it, Dr. Slater? Do we need to save the honeybee?
For sure. I mean, you mentioned that a lot of food that we depend on every single day, like 1/3 of what we eat, depends directly on, bee pollination, and without honeybees, there'd be a lot of, fruits and stuff on the shelves that we wouldn't have at the same rate.
There you go. So with something we simply must do, there's no way to get away from not doing this. Okay. Well, let's start with what is it going to take to make a more effective miticide? Amitraz worked for 20 years, doesn't work anymore. What do we do?
Yeah, so one thing we do is develop a brand new treatment, right? A new miticide that works against viral mites, but then we're still kind of in that vicious cycle, right? We develop a new treatment, mites become resistant to that, and we develop a new treatment, they become resistant to that. And so, to me, the most sustainable solution is breeding. And breeding's been successful. We can breed bees that can fight the viral mites. And so to me, that's really the best route for beekeepers.
So not looking for a new miticide then. I don't hear much hope in that direction.
Well, I think there are researchers that are looking for different miticides, even different biocontrols, right? Like nematodes, can pseudoscorpions, can they be effective against mites? But will they work effectively enough on a large scale to support beekeepers? So I think immediately, people are looking for the next silver bullet or next treatment, and there are some in the works, but is that like a long-term solution? That's tough to say.
Okay. What about fewer pathogens? Any way of getting rid of the pathogens in our environment?
Yeah, really with the viruses, the only way to manage the viruses is by managing the viral mites, and we don't have a good way to manage virus levels. We don't have good treatments against viruses, and so that's a really big problem.
It's pretty much true with all of our afflictions of human beings too. We don't have a way of dealing with viruses, do we?
Exactly. So, we are trying to breed bees that can tolerate the viruses, and so that's one thing that we're really focusing on. But I don't see anything in the works for some kind of virus treatment.
There you go. So not much we can do there. Okay. What about pesticides? Fewer pesticides. Is there any way we can talk farmers into using fewer pesticides?
Yeah, it's really tough, right? Farmers have their job to do, they have their businesses to run, and so they're using a lot of different chemicals to treat their pests. And I think a lot of that comes with education. If you can educate them better on different strategies to manage pests, they could lower their use of pesticides. But that's a whole other extension office that can work with them. One thing I'm really working on here in Texas is trying to increase communication between farmers and beekeepers. If we can have a route for them to actually communicate with beekeepers, they can at the very least move their colonies or cover their colonies. So, one thing I've been really focused on is communication. Even for applicators, can we do some education to see that, hey, there's some bee-friendly options that you can do that can still help with the problem, but still have some benefits for bees. So we are working with applicators to find, something for them. I know some states like New York State has done some bans for neonicotinoids and some other chemicals. I'm not sure if that's a route. I know they've done it in the United Kingdom, but then if you ban a pesticide, is the alternative worse than what they're using now? That's always the biggest question.
Yes. And neonicotinoids is probably one of the biggest problems that we're having with respect to insect die-offs, correct?
Yeah, neonicotinoids is it works really well. It's used really widespread, and that's why so many farmers, use it because it's so effective against a lot of different pests. But the problem is it's systemic. What systemic means is it can transverse entire plants, so get into the pollen and the nectar, and it can cause that exposure for not only the time of application, but even months afterwards. And so bees can continually be exposed to that, even if a farmer applied that, 2 to 3 months before.
Wow. When I first came to California many years ago, I remember driving through the Central Valley and certain times here you'd have your car would be covered with bugs, dead bugs. Not so much anymore. You could you could drive through farm country and not have a lot of bugs splashed on you. So it seems to me like we've gotten rid of a lot of bugs.
Hmm. No, exactly. And that's sort of the goal of pesticides, right? I know,
Yep.
with mosquito abatement is to kill all, insects, to do some more urban pest management, which is really important, but also can have these indirect side effects, with the bees and pollinators.
There you go. So that's the situation. You get rid of one problem and another problem pops up on it. There you go. So fewer pesticides, good luck on that one. I guess there's one way consumers can actually have an impact on pesticides, and that's to buy organic food.
Hmm.
Because if consumers buy organic food, that means no pesticides or chemicals in the field. And perhaps that's one way that consumers can weigh in on that issue and then of course improved nutrition. Where do we
Yeah,
get better food for our bees?
Yeah, I think nutrition is something that everybody can get on board with. I think even farmers, they may not be able to change their pest management, with pesticides and things like that. But I think there is a concerted effort for conservation, whether they want to use it just for hunting land or whether they want to support bees and pollinators. And so, one opportunity there is, there's part of their land that they're basically throwing money into that's not producing the crops that they want. Can they put that small strip of land into kind of pollination or some, better food crops? How about row cropping? So if you see these kind of fields and fields of almonds, can they plant bee-friendly forage in between the almond orchards? Or even solar farms, can you plant bee-friendly habitat there? So I think there's a lot of areas, of the country that we could plant more bee-friendly habitat and invest more into that.
Good. There's a really interesting conflict out here in California, the salad bowl of the world, uh, that has become very frightened about different kind of toxins that could possibly get into the salad bowl. So farmers are encouraged to get rid of all extraneous plant matter. And there are groups of people like the Wild Farm Alliance, for example, that try to encourage farmers to plant various kinds of plants or animal friendly plants along the borders of their fields. So, and it's an interesting conflict to watch evolve. You like to see critters in the field,
Yep.
but there it is. Good. Okay. So let's talk a little bit then. Let's turn to your effort to build a better bee. So describe what the university wants you to do.
Yeah, so our major goal is to launch a breeding program, and our major initiative is to breed bees that are, resistant to the varroa mites. And these traits. So you imagine a honeybee colony. There's 40,000 bees within a single colony, and so they have these really cool social behaviors. One is hygienic behavior, and with this hygienic behavior, if you breed the right way and you breed for the specific traits, you can actually breed bees that can find the mites and kill the mites. And so we're kind of focused on two different traits. So one is this trait called varroa sensitive hygienic behavior, or VSH. What that means is the mites are really smart. They jump into the cells right before the workers cap them with wax. Because once they're capped with wax, the mites are pretty much hiding inside the cells. The bees can't find them, and the treatments can't kill the mites inside the cells. That's been a really big issue. But if you breed for this trait, the bees can actually smell the mites inside the cells, uncap them, and basically cause them to be non-reproductive or sterile. And so we're kind of focusing on that one VSH, viral sensitive hygienic trait. And the USDA facility in Baton Rouge has been very successful and hasn't treated for mites for a very long time because the bees are really good at taking care of the mites. The second trait that we're adding on is this grooming behavior. So the mites can actually find the bees can actually find the mites on the back of the bees, find them, kill them, and chew their legs off. And so it's called a mite biting behavior. So we're kind of trying to target mites from two different directions, inside the cells and then the back of the workers.
Wow. Tell us how you go about doing the work then. You really have to set up some good experiments with controls, correct?
Yeah, so as of right now, we're really focusing on the stocks that have already been selected for it. And so in the late 1990s, the USDA Bee Lab in Baton Rouge, they started selecting for this trait. So they've already done most of the hardcore selection. But in order to continue that, it's really time consuming. You have to open up 100 cells and measure how many mites are actually inside the cells. For the mite biting behavior, you have to individually count all the mites that die on the bottom of the colony. And so it's a very, very time consuming task. But one thing that we are developing is a genetic test. So, imagine like a 23andMe test. It can tell you if you're more likely to have certain hair color or eye color. And so if we can develop a genetic test, we can have beekeepers send us samples and we can say, hey, this colony has these traits. You should breed from this colony. And because that's been the really limiting factors. Beekeepers don't have the time or the capacity to do that. And I think this genetic test can really change that.
Don't have the time to really keep track, do you? When you have a commercial load of 1,000 hives to deal with, you're just dealing with hives.
Yeah, and if you think about the bee industry, and it's different than any other industry. The beekeepers are in charge of honey production, they're in charge of pollination, they're in charge of queen production, and they're in charge of breeding. Other industries, they have people that are dedicated towards breeding, whereas the beekeepers, they're in charge of everything, and they just don't have the capacity or time to run a full-fledged breeding program along with their everyday operations.
So it's a lot of extra work, and that's why they brought you in.
Exactly. Yep. So my goal is, if we can run the breeding program, we can do all the hardcore labor, we can get the dedicated breeders, and we can breed the better bees and then distribute those to beekeepers, across the country. And what's really great about East Texas is, they produce about 35% of the queens across the country, and California produces about 50%. So if you can, breed these bees and distribute to the right people, you can have a massive impact, not only locally, but across the country.
So how do you go about breeding the bee? What is the process? I mean, we're familiar with how cattle are bred these days and horses and so on. We use artificial insemination. So is that how you go about breeding the bee?
Exactly. Yeah. So one thing we utilize is, artificial insemination. So we actually do that process here with honeybees. And so basically we choose the colonies that have the right traits, and then we do crosses with them with artificial insemination. And I think that'll be a big game changer because, with honeybee mating, you can't lock a queen and a male in a pen and have them mate with each other. They fly out and they mate in the air in a 3 mile radius. And so the only way to actually control who the queen mates with is through artificial insemination. Otherwise, you just lose the genetics and lose the traits.
Wow. Well, okay. How do you go about artificial insemination? First, you got to get the semen.
Yep.
So this sounds like a very microscopic job.
Yeah, so we have dedicated queen stations. We actually have an artificial insemination course, this weekend, just teach beekeepers how to use it and how to use the equipment.
Wow.
It takes a while. It's very technical because bees are really small, so it takes a long time to get the expertise in it. But for me, I can inseminate maybe 100 queens per day. So if you get really proficient at it and get the expertise in it, you can inseminate quite a few queens. And probably the hardest part is not necessarily the insemination part of it, but evaluating the traits, because some of these traits can take a long time to select for, but also measure.
And it is a selection process. So you have to have a way of making that selection. You have to know what traits to look for. And you, as you said, you were looking for two specific traits.
Yeah, so we're selecting for those two traits, the mite biting behavior and then the VSH behavior. We're also really interested in honey production. We're interested in viral tolerance. So one thing we're doing is we're actually injecting bees with viruses to see if they die or they don't die from the viruses. Because we think about the two major P's, viral mites and the viruses. We're trying to select for those two traits primarily, while still retaining honey production, which is what beekeepers really want.
More honey.
More honey, exactly. And
more honey from each hive.
yeah, and one problem with this breeding is, when you select for a trait, you typically have a decrease in honey production. So we're trying to not only breed for these traits, but still retain honey production. But, beekeepers lose even 10% less colonies. That makes up for any lost honey production they may have. Yeah, I think so. If you're losing 40% of your colonies each year, and I've had a lot of people, reach out to me and tell me, hey, Amitraz isn't working anymore. We need to invest more into breeding and genetics. And so I really think it make a big difference, if we can get some buy-in and show beekeepers the value of, breeding and using these stocks. I think we can really change the industry.
So breeding is probably the one thing we can control. And it doesn't seem like we have much control over pesticides. Farmers are going to use pesticides, over nutrition, because farmers are going to plant fence post to fence post, and they're going to plant commodity crops, and it's like living on white bread or something like that. So the one thing we can do is build a stronger, more effective bee.
That's exactly what I tell beekeepers too. I do understand like poor nutrition and pesticides is still a major issue and it's going to be a major issue. But the one thing you can do right now is to breed against viral and viruses, and we can start breeding against those challenges and breed better bees against those challenges and then, fight that larger battle later. But, as of right now, if we want to do something that we can actually really deal with is the viral mites and viruses. And to me, my opinion is if we focus on breeding, I think we can really maybe not eliminate the problem, but at least, lessen it so beekeepers don't have these large losses each year.
Well, Dr. Slater, a lot of people love bees. And they love the concept of bees, and they love seeing bees flying around, and they love doing what they possibly can, probably to make it easier for bees to live, because they do make our life beautiful, not only in the food that they provide, but in how they make flowers too. They increase the foliage of our planet. So, what can we do to help you and the rest of you in your community of bee people?
Yeah, I think the first thing you can do is, in your whether you have a house and you have a backyard, try to plant more bee-friendly forage. You may not be able to plant enough to support one honeybee colony, but everything you plant makes a big difference. So, even if you have to have a well-manicured lawn, if you have a pollinator garden, that can still make a big difference for bees and pollinators. And try to lessen the use of, pesticides that are toxic to bees. But most pesticides have a label on them and they tell you whether they're toxic to bees or not. So, trying to lower the amount of pesticides. And so those are probably the two major things that, anybody can do. The final thing is, try to buy local honey. So go to the store and buy, honey from a local beekeeper. They put a lot of time and money and effort into, bottling that honey. And if you never kept bees before, you may not realize how hard it is to put that bottle on the shelf, but it takes a lot of time and effort. And a lot of them are losing a lot of colonies to put that service on the shelf. So by buying local honey, you are supporting the local beekeepers.
And by buying organic, you're supporting the environment in which the honeybees can thrive as well, because you're reducing the amount of pesticides in the environment, and that is a significant stressor for sure. So Dr. Garrett Slater, who is the Texas A&M University Extension entomologist, who's charged with a very interesting job of building a better bee there in Eastern Texas. So we appreciate your joining us today, Doctor, and thank you for what you're doing for our world.